So this is 8088 motherboard which I recently bought on eBay. It was sold as not working, and I thought it would be quite interesting to get it working again. The same seller was selling the boards for just under £100 fully working. This one was advertised at £35. I made an offer at £25. And the seller came back with £30 and I accepted, which I think was a fair price. Particularly because on this board all the major chips are there and they're socketed as well, so even if the board was a complete write-off, I can actually sort of reuse some of the Intel parts in one of my other CPU projects. So this board is a turbo board. It does 10 MHz and 4.77 MHz, a standard IBM PC clock rate. It's got 640k of RAM in these two banks here. These are 256k DRAMs and these are 64k DRAMs. Interestingly, it's got an NEC V20 CPU, which is 8088 compatible. This is this chip here. So looking at the board, I've got the impression that it's been fiddled with at some point in the past, and possibly some chips have been changed, I'm not sure. This is the clock generator IC, and it runs normally at 14.318 MHz. But down here we've got a 30 MHz crystal with a LS04 inverter. And that also goes into the clock chip, and there is a turbo switcher, so it can switch between the 10 MHz clock, which is a third of the 30 MHz crystal, or 4.77 MHz clock, which is a third of the 14.318 MHz clock. And this chip doesn't sort of seem to fit with the type of the other chips. The main chips here are all NEC Japan, and so it just made me wonder whether this was original or not. Can't really see the date code on here. It's a Mitsubishi chip and I can't read the date code, so I don't know if it's similar to the other chips. Also, this here is the 8288 bus controller. This one's a CMOS version, which again seems a little bit strange given that none of the other chips on this board are CMOS. So again, I wondered if that might have been something that's been swapped out at some point. There's a chance that someone else has tried to repair this board and possibly given up, so that might explain why some of the chips are a little different. But I'll be going through testing these chips on the oscilloscope to find out what basic level of functionality we have. But just to go over the board, we've got 1, 2, 3, 4, 5, 6, 7, 8 ISA slots. We've got the CPU slot here. We've got an empty socket for an 8087 maths code processor. We've got the keyboard connector here, which needs an XT keyboard. Luckily I do have one of those. Thankfully I kept that. This is the bus controller IC that generates the IO read, IO write, memory read, memory write, the various strobes. We've got an 8353, which is the timer chip. It's got 3 16-bit channels and one of them is used for speaker beep. We've got the 8259, which is the IRQ controller, and that gives us, I think it's 8 interrupts. 6 or 7 of them are available on the ISA bus. This is the BIOS ROM. It doesn't look original. And I've recently dumped that, and so I'll show the contents of that in this or a different video. The 8237 is a DMA controller. I find it quite interesting that IBM implemented DMA on the original PC. For home computers at that time, I think very few, if any, implemented DMA. But it is used for the floppy controller and it is used for the refresh. And I'm hoping to look a bit deeper into that because I'm fascinated how that actually works. Then we've got the 8255, that's a parallel I/O chip. It's got 3 ports, 2 8-bit ports, A and B, and port C, which is 2 4-bit ports. and that's used for the keyboard. There's some extra TTL supports also required for the keyboard circuitry as well. One of the reasons, again, that I chose this to buy from the eBay vendor, who had some other broken 8088 motherboards on sale, is this one has no custom IC chipset IC. It's all TTL, and so the design's going to be almost a clone of the original IBM PC, and given there's no custom chips, it means it should be easy to repair, and it probably follows very much along the lines of the original IBM PC. And thank you to IBM for making the reference manuals available. Again, it's going to help in making the repair possible. I have noticed that the ground pin of the EEPROM has a bodge wire soldered onto it, so the pin come off at some point. So again, I'm suspecting that's not original. And I also noticed the same with one of the DRAMs. It was sitting a little strange in the socket, and again I saw that there was a pin that had a wire soldered to it. So again, a wire has fallen off that DRAM. I'll leave it in for the moment. When I come to test the memory, I'll see if that particular RAM's a problem or not. But the idea is to make a repair. I've been working on my own 8088 CPU card, and I've made good progress with that. So I now have a lot more knowledge about the basic IBM architecture, how the BIOS works, what the various chips are supposed to do, and so I'm looking forward to making a repair. So looking at the board and looking at the chips there are, I was interested to try and figure out if they were all original and possibly get an idea when the board was manufactured. The CPU's an NEC-V20, the date code's not clear, but it's a little unusual, as I would have expected an Intel 8088 or AMD part. A part would need to do 10 MHz. It's a bonus to get a V20. Whether it's original or not, I've got no idea. The 8284 clock generator, again, that has a date code that's not clear. The 8288 bus controller, that's CMOS, which is unexpected, and it's got a date code of 1987, so you know it's the right time frame. The main peripheral chips are all NEC brand, all date code 1988, so I'm pretty happy that they're original. We have the programmable DMA controller, the programmable peripheral interface, the 8255 parallel port chip, a programmable interrupt control chip, and the programmable interval timer chip, and they're standard to all PCs. The DRAM has a bank of 256K. These are Hyundai, date code 1989, and the 64K are a brand I don't recognise. Looking at the TTL chips, the date codes range from 1986 to 1989, but there are quite a number of TTL chips with that brand I just don't recognise. But it does all point to the fact that this motherboard dates from 1989.